This is your homework video for lessons 2.7 and 2.8. We complete these together because they're so similar. Looking at related facts and fact triangles, starting with addition and subtraction in 2.7, and then multiplication and division in 2.8. So starting with homework from 2.7, we're on page 109. We're doing 1 through 11. So starting on number 1, we're looking at this triangle. What are the related facts of this triangle? So we can read this any direction that we want. So starting from, let's go side to side here. If we're going to add these together, we have 0.23 plus 0.44 equals 0.67. And then you can always go the opposite direction as well. 0.44 plus 0.23 equals 0.67. So we went around this way, we went around this way. You can also read it from top to bottom. So 0.67, when we go that direction, we are subtracting. So minus, I'll go this way, 0.44 equals 0.23. I can also go the opposite way, 0.67 this direction, minus 0.23 equals 0.44. And all of those facts will hold true. So I can add these together either direction and get 0.67, or reading down, I can subtract either one of them from 0.67 and I will get the other. So going on to number 2, we're going to go ahead and make a fact triangle and then write the other facts. So subtraction goes on top, addition goes on the bottom. So you got to look at what's given to you. Sometimes you're given subtraction, sometimes you're given addition. If it's addition, then those two go on the bottom, the 82 and the -5. Those get added together to make 77. So that's what it's going to look like. Now, they already gave you 82 plus -5. They want the other 3 facts. So I would always just go the opposite way to start. So -5 plus 82 equals 77. And so we've had an addition and addition. That means we're just missing the 2 subtractions. So we're reading it from top to bottom. So 77 minus this one and 77 minus this one is always going to equal the other. So 77 minus -5 is 82. 77 minus 82 is -5. Okay, number 3, fractions, but they've already given you all the answers, right? They gave you the 3 numbers. You don't have to do any work. Just put them in the right spot. Now, this is subtraction, so we need to be careful. When we read these subtraction problems, we're always reading from the top. So that means the -1/8 goes up here, and we're minusing on the way down. So you can actually put the 3 7/8 anywhere you want. I'm going to put it here, but you could have put it on the other side. But you have to put the -1/8 up top because you're subtracting something from it. And so we always read these fact triangles from top to bottom. So we've already done the -1/8 minus the 3 7/8. So for our next fact, let's just do the other subtraction problem. So going this way, -4 equals 3 7/8. And then all I'm missing is my 2 addition problems, which is just the bottom 2 being added together. And then the opposite direction. And I'm all set. Okay, so number 4, same idea, except now we have variables, and so we have to trust the process. We can't just double check the numbers with actual arithmetic. So here we're adding together these 2, so they go on the bottom. So we've got the plus here. I always start there. Okay, I'm adding these 2, and I'm minusing from the top. That means the 6x must be here. You know, we can double check ourselves with algebra when we do these facts. So we've already got one of the additions. So let's do the other addition, go in the other direction. 5x plus x equals 6x. So now we have this addition problem and this one that we need 2 subtraction problems. So 6x minus 5x equals x. And then the other direction, 6x minus x equals 5x. Go back and make sure that makes sense. Is 5x plus x 6x? Yep. 6x minus 5x is x. That's true. And 6x minus x is 5x. So those all do make sense. All right, number 5. We're going to solve this equation 2 different ways. So letter A, we're going to solve it using a fact triangle. So let's go ahead and make a fact triangle real quick, and I'll show you how to use it to solve. So these are being added, so I'm going to put them at the bottom. Y and -6. If you want to put in parentheses, that's fine. So what you want to do is you want to isolate the the variable if you're trying to solve this problem using a fact triangle. So you're going to come up with the related fact that has y isolated in terms of your equal sign. When you write equals, we want y by itself. So that means these two facts have to go on this side. And if I'm relating these two facts in the triangle, I'm reading it from top to bottom. It's 14 minus negative 6, and that equals y. And so all I have to do now is actually compute that, and hopefully you can do that in your head, but if not, just plug it in your calculator and it's 20. So I've created a set of facts that will solve for y. 14 minus negative 6 equals y, is y. So what is it? Just go ahead and solve it, and it's 20. Now for part B, we're going to use the addition property of equality. This is basic one-step equation work. Hopefully it seems familiar from middle school. So again, we're trying to isolate the variable when we're working with this, meaning it's completely by itself on one side of the equal sign, then we know what it's equal to. So we want this to look like y equals, and then a number on the other side. We already know it's going to be 20. How do we get there using algebra? So what we want to do is cancel this negative 6 out, basically. And so we want to get it to a 0, because we don't have to write y plus 0. We can just write y. So we need to get negative 6 to 0. So how do I get it there? So from negative 6, how do I get to 0? I add 6. Now, I'm never allowed to just randomly add things to an equation without doing it on both sides. So the addition property of equality states that as long as I add to both sides of my equation, then I haven't changed the fact that the two sides are equal. So as long as I add plus 6 to both sides, I maintain the equality here. So this goes away, and I'm left with just y, and then 14 plus 6 on this side is 20. And once y is isolated, and it says y equals, now I know the actual value of y equals 20. So two different ways to solve it. Eventually, we'll kind of get away from the fact triangles, and we'll just start using the algebra here. But this is just another way to think about it. Very useful in just honing your knowledge and maybe growing your knowledge. Maybe you knew how to do this, the basic cookie cutter stuff, but this is going to grow your knowledge as well. All right, so number 6, we're going to number 11. Write 3 other related facts. So if it helps, draw the triangle real quick. This is subtraction, so 7's up top, minus b gives me negative 8. So my other subtraction would be 7 minus negative 8 equals b, going the other direction. And then my other related facts are my addition in both orders here. So b plus negative 8 equals 7. And then it says, what's the value of b? So if I'm going to use related facts to solve, I want b isolated. So that would be this one, because b equals whatever this is. So all I have to do is do the math. I don't have to do any algebra to solve it. Of course, we could solve these, okay, and we could isolate b using algebra. But with the related facts, if b is already isolated here by itself, it says b equals this answer. I just need to solve this. Okay, and then 7 minus negative 8 goes plus plus. And so for part B, the actual answer here, you go plus plus, is just 15. So you can use related facts to solve it. Find the related fact where the variable is isolated, and then just do the math. I'm going to squeeze 7 in here because it's so easy. Fill in the blank. 10 plus negative 10 is negative 10, obviously. So we study kind of some of the properties of 0 in this section, so just basic. 0 plus anything is the number. Number 8, why is 0 called the additive identity? So any of our identity properties, whether it's the additive identity or the multiplicative identity, it's what are you adding or what are you multiplying by to get the identity, which is the original number. So 0 plus negative 10, I get the identity. I get the original number, negative 10. So why is it called the additive identity? Because adding 0 to a number results in the same number. So give 2 examples that are additive inverses. Okay, so going away from additive identity, additive inverses. So additive inverses are 2 numbers that when you add them together, you get 0. So 5 and negative 5 are additive inverses, because if I do 5 plus negative 5, I get 0. And you could have given any opposites basically, and so I just gave away the answer to number 10. What's another name for an additive inverse? Is an opposite. Okay, if you add two numbers and you get 0, you have opposites. Because 3 plus negative 1 is not 0, it's 3 plus negative 1. 5 plus negative 10 is not 0, it's 5 plus negative 5. So you have to be adding opposites together, and those are called the additive inverse, because you're adding them together. They're basically canceling each other out, and you are getting 0. So what's the additive inverse of negative x? What would I add to x to get 0? Well, what's the opposite of negative x? That's x. If I do negative x plus x, I get 0. So that's the additive inverse. All right, so that was lesson 2.7. We are skipping to page 117 now. And we are doing 7 through 16. So now we're looking at multiplication and division facts. So starting on number 7, finding the reciprocal. So the reciprocal is kind of like the additive inverse for these. Okay, so we're going to follow some rules in terms of flipping our fractions and things like that. But the reciprocal, now it's not going to get us 0, so it is different than the additive inverse. But it's always going to get us 1. So what do we multiply the number by to get 1? That's what the reciprocal does. Now, the way to find the reciprocal is to take the fraction. So actually number 8, we can start there. It's a little easier because it's already in fraction form. The reciprocal is just the flipped version of the fraction. So it's 7 over 4. But why is that the reciprocal? Everyone always memorizes, oh, the reciprocal is just the flipped fraction. But why? Can you explain why it is? It's because if you take the original number and you multiply by the reciprocal, you get the number 1. Straight across I get 28, straight across I get 28. Anything over itself is 1. So that's what the reciprocal is. We need to know what it is, not just how to find it. It's the number when you multiply by, you get 1. And that only happens with the flipped version of the fraction. So number 7, we have negative 6. Well, it's a whole number, so if I want to turn it to a fraction, I put it over 1. We should know that. So if I'm going to multiply this and get 1, I need the flipped version of this. So I need a 1 on top, I need a 6 on the bottom, and now right now this would be incorrect because if I multiplied, I'd get a negative number, and I don't want a negative 1 answer. If it is the reciprocal, I get a positive 1 answer. So when I flip this, it needs to remain negative, because now if I multiplied it, first of all, negative and a negative is a positive, and I'd get 6 on top and 6 on the bottom, and that's 1. So the answer here is negative 1, 6. Now, if you want to go ahead and put the negative down in the denominator because you saw it on the 6, you move the 6 down here, so you want to move the negative with it. That's fine. You can write this as negative 1, 6 with the negative up top. You can write this as 1 over negative 6, although you'll hardly ever see that. And you can also put the negative just out front of the fraction completely. All three of those are perfectly fine. They all say the same thing. Okay, so we don't want to get tripped up by that. All right, number 9. Here's that word again, identity. So the additive identity is when we added by 0 and we got the same number. So what number is the multiplicative identity? Meaning we multiply by that number and we still get the same number. So we know that that is 1. I multiply anything by 1, I still get the identity. I get the actual number I started with. Okay, number 10. If a times b equals 1, then what is true about a and b? So the only way you're going to multiply two numbers and get 1 is if they are reciprocals. And you need to start using that word, reciprocals, the flipped version in terms of the fraction of each other. That's part A. In part B, if we know that a times b equals 0, then what's true about a and b? A equals 0, or b equals 0, or both of them equal 0. It's possible both of them do. But we know one of them is equal to 0 if we multiplied them together, and we got 0. All right, we're going all the way to 16. So number 11, explain in your own words why 0 does not have a reciprocal. So if I take 0 and I say, let's say I put it over 1, because it is a whole number, right? 0 over 1 is 0. But if I go ahead and I try and flip that, and I make it 1 over 0 and try and multiply across, first of all, let's say you could do that, but you can't. We'll talk about that in a second. But let's say you could. You're going to multiply straight across here, and you are going to get 0 over 0, which is still not good. But let's say you, in your head, said, oh, well, that's 0 and it's not 1, so that's why you can't get the reciprocal. So that line of thinking isn't terrible. But the problem is this, and then it also results in this. You cannot divide by 0. If you try and do it in your calculator, it's going to give you an error. Okay, so dividing by 0, it's not defined, is what you're going to see in the textbook. They're going to say dividing by 0 is not defined, but you cannot divide by 0. All right, number 12. What number satisfies the following sentences? So what number, when you do 0 times that number, is 8? There is no number. 0 times anything is going to be 0. Letter B. 0 times what number is 0? That can be any number. 0 times any number is 0. And then letter C. 7 times some number is 0. I know that number actually is 0. The only time if I multiply 7 by something and get 0 is if that number is 0. I'll just keep going down. 13. So if 4 times x equals 0, I don't need to do any fancy algebra. 4 times something got me 0. Solve the equation. X must equal 0. That's the only way. This has to be 0. 4 times 0 is 0. 14. 0 times something gets me 1/2. That's not possible. There's no solution here. It's impossible to plug a number in, multiply by 0, and get 1/2. 15. 0 times a equals 0. So what number do I plug in for a to get 0? Any number. 0 times anything will get me 0. And obviously we all know that. We're just kind of defining this now. And then number 16, if I have 3b minus 3b, it equals 0. What number can I plug in for b to make this true? Well, if I do 3 times any number here and 3 times any number here, since they're both b's, that means I'm plugging the same number in both spots. So 3 is getting multiplied by the exact same number, regardless of what you choose, both times, which means you're going to get the same product, the same answer to your multiplication. And so it's going to be some number minus that same number equals 0. And so any number here can once again be the solution.